This is the AQA AS Maths papers from May 2018, paper 1. We're on question 13 from the mechanics. We're told a vehicle which begins at rest at point P is travelling in a straight line. We're told that for the first 4 seconds we have constant acceleration of 0.75 meters per square second. So if this is my time 0 to 4, I have constant acceleration of 0.75 meters per square second. For the next 5 seconds, that's between 4 up to 5, up to 6, up to 7, up to 8, up to 9. Just checking I don't make a mistake with the length of time here. The vehicle moves with a constant acceleration of negative 1.2. So again, it's constant acceleration of negative 1.2 meters per square second. The vehicle then immediately stops accelerating and travels a further 33 meters at constant speed. So no longer, so it's between 9 onwards, and I then have constant speed, not constant acceleration, for 33 meters. And I'm asked to draw a velocity time graph on the grid. Let's look at what I'm expecting from a velocity time graph. Well, this bit is going to give me a positive gradient of 0.75 meters per square second. This is going to give me a negative gradient of 1.2 meters per square second. And this is going to be a horizontal line, but it has to go only as far as allows me the area under it to give me 33 meters worth. So let's see what happens. I think a useful thing to do here is also to work out what my speed is at the start and end. So my speed at the start of this would be 0, because it's starting from rest, and it goes as far, well, 4 seconds, increasing at 0.75, it's going to go up to 3 meters per second. So at 4 seconds through, I should get to 3 meters per second. Let's see what happens here. We're going at negative 1.2 for 5 meters per second. Well, we're starting at 3 meters per second because that's going there. And we're going to go down by 5 lots of 1.2, which is 6 less. So that's going to drop to negative 3 meters per second. I got that by saying my change of speed will be worth 5. It's 5 seconds worth times 1.2, which gives me 6. Negatively, it was at 3. It's going to drop to negative 3. And here it's going to go constantly at that negative 3 value. So my graph will end up looking something like this, perhaps not quite to scale, but it's going to go between 0 and 3, which will go up like that. So 4 seconds through, I get to 3 meters. That's my velocity in meters per second. That's my time in seconds. So I'll get to that point. Then 5 seconds later, I'll get to negative 3, which is down here. And that's dropping a little bit at a higher gradient than that. And now it's going horizontally for 33 meters per second. Well, sorry, 33 meters. If it's got 3 there, that area there is going to be times in by 3. If that goes to 9, this is going to go as far as, if it goes for exactly 33 meters, a point where that 3, which is that height there, times that distance gives me 33. So that distance therefore must be 11, therefore that must happen at 20 seconds. So that's what my velocity time graph looks like for 13 part A. We're told then to find the distance of the car from P after 20 seconds. Well, that's all the way to the end. And we're told it started at P. So basically, it's what's the total distance. Now, remember, this is going to be, the velocity time gives me a displacement, really, when I look at the area beneath it. So let's look at a number of areas. I've got this area underneath here, and I've got this area sort of above the line there, and how I might go about splitting it. I ought to find out where it crosses here, because then I consider it in 3 parts. I consider this triangle between 0 and this point, a second triangle between that point and 9, and thirdly a rectangle between 9 and 20, which we know is 33 already, actually. We know that bit's worth 33 meters. So can I work out what's going on here? Well, this triangle should be easy once I've calculated where it crosses there. So at that point, that starts at 3 meters per second and drops to 0 at a gradient of 1.2. Remember, we had a gradient of 1.2 there. So at some point I had 3. Let's call that time. Shall we call that distance, in fact? Let's call that distance A. And so that, in fact, better than that. Let's call that some distance T1. So at T1, I've taken my 3 meters per second and I've reduced it down to 0. And I've done that by going an acceleration of 1.2 meters per square second, and I'm multiplying it by a time distance of T1 minus 4. So that value, that acceleration times that time must equal -3. Because I've taken that 3 and brought it down to 0. And I can then solve for that value of T1, which will give me T1 minus 4 is going to be -3 divided by 1.2, which gives me -5/2. So T1 then is 4 plus that value, which is 1.5, which gives me a nonsense answer because it must be greater than 4, obviously. So I've done something very silly here. Let's work out what's gone wrong. I've got to say that I've got a velocity there of 3, it drops to 0 here, and the gradient there is 1.2. How long is that going to take? Well, another way I could do it is at 5 seconds, my velocity must be from 3. It's gone down by 1.2, which gives me 1.8 meters per second. At 6 seconds, I was at 1.8. It's gone down by another 1.2, so now it's 0.6 meters per second, and you can see clearly it's going to be 6.5 seconds. I'm at 0.6 minus another 0.6, which gives me 0 meters per second. So that means this should be my value. That should give me 2.5 seconds beyond there. That distance there then is 2.5, which means this T1 is 6.5 seconds. So my value I got here was close, but not quite right. The analysis was pretty weak here. I'm sorry about that. So I get 2.5 seconds is when that's going to happen. I'm still looking for the distance, haven't got there yet. Let's go to here. So this triangle here between 0 and T1, so let's say 0 up to 6.5 seconds. The area under it is half times the base, which is 6.5, times the height, which is 3, which is 0.5 times 6.5 times 3, which gives me 9.75. And then I've got between 6.5 seconds and 9 seconds. It's gone across. It's again half times the base there is 9 minus 6.5 times the height here, which is again -3, which gives me half times 9 minus 6.5 times -3 gives me -3.75, and then between 9 seconds and 20 seconds is -33 meters. I add all these values together, the negative sign there, and say 9.75 minus 3.75 minus 33 gives me a value of -27 meters. So my final answer, the distance of the car must be positive, of course, so I get distance equals 27 meters.